Hello, I'm Seema and welcome to part 13 of the chapter States of Matter. In this video, I'm going to tell you about the combined gas law. We have studied that there are four variables or four properties which determine the behavior of gases. These four properties are pressure, volume, temperature and number of moles. When two of these are constant, the different gas laws were relationships between the other two when two of these were kept constant. For example, Boyle's law had a relationship between pressure and volume, assuming that the temperature and number of moles was constant. Charles' law had a relationship between volume and temperature, assuming that the pressure and number of moles was constant. And Gay-Lussac's law was a relationship between temperature and pressure, assuming the number of moles and volume to be constant. If you notice, I've chosen these three laws, not the Avogadro's law where there was a relationship between volume and number of moles, taking the pressure and temperature to be constant. We are not taking that into. Here in the combined gas law, it was assumed that the number of moles is constant. And now the other three laws were combined, assuming that the number of moles was constant. So let us first just revise the three laws. Boyle's law was a relationship. Boyle's law tells us that when number of moles and temperature is constant, pressure is inversely proportional to volume. So what was the relationship that we got here? That P1 V1 is equal to P2 V2. This is the relationship that we got in the case of Boyle's law. In the case of Charles' law, we said that volume is directly proportional to temperature. Volume is directly proportional to temperature when number of moles and pressure is constant. So what was the relationship? The relationship was V1 upon T1. V upon T is constant. Therefore, V1 upon T1 is equal to V2 upon T2. This was Charles' law. The Gay-Lussac's law was a relationship between pressure and temperature, and he said that when volume and number of moles is constant, the pressure is directly proportional to temperature. Therefore, the ratio pressure upon temperature is constant. So the relationship can be written as P1 upon T1 is equal to P2 upon T2. Right? So we find that these are the three relationships that we get from Boyle's law, Charles' law and Gay-Lussac's law. The combined gas law assumes that number of moles is constant. Therefore, this relationship, if you see, you can actually combine them. Pressure and volume are inversely proportional. Therefore, the product PV is constant. Pressure and temperature, they are directly related. Therefore, their ratio is constant. And volume and temperature, they are also directly proportional and therefore their ratio is constant. So can we not just put this temperature here and get a relationship between all these? It will be a combined relationship. So that is what was done in the combined gas law, assuming that number of moles was constant. This relationship was brought into or was written down. And I'll explain it to you why this relationship is right according to these laws. P1 V1 upon T1 should be equal to P2 V2 upon T2. This was the combined gas law. Right? Let us assume that we are talking of Boyle's law. If we are talking of Boyle's law, we already know for the combined gas law, number of moles is already constant. According to Boyle's law, temperature should be constant. Therefore, T1 and T2 should be equal. Therefore, P1 V1 should be equal to P2 V2. Right? In the case of Charles' law, it is now pressure that is constant. So if you apply that in this relationship, P1 should be equal to P2. Therefore, V1 upon T1 should be equal to V2 upon T2, which is Charles' law. If you take Gay-Lussac's law, and here it is volume that is constant. Therefore, V1 should be equal to V2. Therefore, the ratio of P1 upon T1 should be equal to P2 upon T2, which is Gay-Lussac's law. So we find that the combined gas law, if you just learn the combined gas law, you can actually solve problems of all the other three laws. You don't really have to memorize what relation is what, at least not For conceptual questions, of course, you must know the difference. But for numerical problems, if you just know the combined gas law, you would know what value to plug in where. And you would arrive at the law that you are required to use. You will still get your answer. So this was about the combined gas law. Just a little idea to explain how combined gas law can be used to explain certain behaviors of gases. Do you know we have these weather balloons? And in a weather balloon, you have a balloon that rises up in the atmosphere, and we have attached to it certain instruments which gauge the atmospheric winds or the movements or whatever the temperature difference is. And the weather balloon collects. These instruments collect data, and that data helps us to know about the weather conditions. Are you aware that when the weather balloon reaches a height of about 27,000 meters, it bursts? What is the reason for weather balloons to reach this height and suddenly burst? And why do they not burst before that? We can understand that using the combined gas law. You are aware that the atmospheric pressure, it goes on decreasing as we go higher up in the atmosphere. You must be aware of this, that as closer, the troposphere is the layer of the atmosphere which has the maximum density of air. And as you go up to stratosphere, then ionosphere, exosphere, the density of air, the atmosphere, it goes on decreasing. So as the density decreases, the atmospheric pressure would also decrease. So as we go up, the atmospheric pressure goes on decreasing. And at the same time, we are also aware that as we go up at higher altitudes, the temperature decreases. Now, these two forces have opposing effects on the volume of the balloon. What will happen when the pressure decreases? According to Boyle's law, pressure and volume are inversely proportional. So when pressure decreases as the balloon goes up, the volume should increase. So the volume of the balloon, it expands as the pressure decreases. But as the volume is expanding, the chances of bursting are there. At the same time, the temperature is also decreasing. So when the temperature decreases, what effect does that have? As temperature decreases, volume also decreases. So there are two opposing forces. Pressure is forcing the balloon to expand, while decrease in temperature is forcing the balloon to contract. There comes a state where the force of expansion exceeds the force of contraction. That is the point where the balloon will expand much beyond its capacity and it would burst. And this happens at 27,000 meters of height. And that is the reason why these weather balloons, they go up and they burst. Right? Interesting? So this is how you can use, all these laws. The combined gas law can be used to understand the effect that two different factors may be having on one of the properties. Because the simple gas laws, they are a relationship between only two properties. But the combined effect of these properties can be understood using the combined gas law. Having understood this, now let us solve 3 numerical problems based on the combined gas law. Give me a minute. Okay, so here is our first question. The volume of a gas-filled balloon is 30 liters at 313 Kelvin and 153 kilopascal pressure. What would the volume be at standard temperature pressure? For combined gas law, you have 6 variables. That is P1, V1, T1, P2, V2, T2. Out of these, 5 will be given to you. You are required to find out the 6th. So what are we looking for here? P1, V1, T1, P2, V2 and T2. These are the variables we are looking for. The volume of a gas-filled balloon is 30 liters, so V1 is 30 liters. At 313 Kelvin, so T1 is 313 Kelvin. And at at 153 kilopascals. So P1 is 153 kilopascal is the pressure, P1. What would the volume be? So volume is asked at standard temperature pressure. The standard temperature is 273 Kelvin and pressure is in kilopascals is 101 kilopascals, right? It's approximately 101 kilopascals. Yes, 101.3 it is, if try to be a little more exact. 101.3 kilopascals is the pressure at standard pressure. So now the relationship is, we are required to find out V2. The relationship we are using is P1 V1 upon T1 is equal to P2 V2 upon T2. Since you are required to find out V2, let us just flip this in order to make it easier for you to understand. So P2 V2 upon T2 is equal to P1 V1 upon T1. We are required to find out V2. So what would V2 be equal to? V2 would be equal to, if we want V2 here, P1 V1 upon T1 remains as such. P1 V1 upon T1 remains as such. T2 goes up here and P2 comes down here. So into T2 upon V2. Right? V2 comes this side and T2 to go to this side goes up here. So this is what we want. Now plug in the values. You have to plug in the values of these 5 quantities to get V2. P1 is 153 kilopascal into what is V1? 30 liters into T2. T2 is 273 Kelvin, right? Divided by, what do we have in the denominator? T1 and V2. T1 is 313 Kelvin into V2 is, sorry, this will not be V2, this will be P2 because V2 is to be found out. So P2. P2 would be equal to 101.3 kilopascals. Now whenever you do this, you would like to cancel out the units to know that the answer, since you're looking for volume, your answer should be in liters. So we should be left with only the liter. Kelvin and Kelvin got cancelled. Kilopascal, kilopascal got cancelled. Now we are left with Kelvin. So when you solve this, the answer you get would be equal to 39.5 liters. This will be the effect. Now do you see the combined gas law again here? What is happening? Pressure is going down and temperature is also going down. So these should have opposing effects on the balloon, just as I explained it with the weather balloon, that both pressure and temperature should have opposing effects on the volume of the balloon. But the combined gas law takes into consideration both these opposing effects, and then whatever will be the resultant volume would be given out by this. Interesting? So this was the solution to the first numerical problem. Let us look at another problem. A gas at 155 kilopascals, again we are looking for the 6 variables, and out of which one has to be found out. A gas at 155 kilopascal and 25 degrees Celsius. The temperature has been given in degrees Celsius. Whenever we use the gas laws, the temperature should always be in Kelvin, and N should always be number of moles and not in grams. Although here N is constant, so we are not talking of N. So temperature should be in Kelvin. A gas at 155 kilopascals and 25 degrees Celsius has an initial volume of 1 liter. The pressure of the gas increases to 605 kilopascals as the temperature is raised to 125 degrees Celsius. What is the new volume? Again, there are opposing forces here also. The temperature and pressure both are rising. So one will have the rising temperature will cause expansion and the rising pressure will cause contraction. So let us see what will be the combined effect. So we are looking for P1, V1, T1, and we'll be looking for P2, V2 and T2. A gas is at 155 kilopascals. 155 kilopascals is the pressure. And 25 degrees Celsius. 25 degrees Celsius, you will add 273 to it and you would get the answer in Kelvin. 25 degree plus 273, let's add this, 5, 6, 7, 8, 2, 298 Kelvin is T1. Now let us come to P2. If the pressure of gas increases to 605 kilopascal is P2, and the temperature is raised to, you have to find out the volume, temperature is raised to 125 degrees Celsius, add 273 to it to give you the Kelvin temperature. So this would be 398 Kelvin. So using the relationship now, V1 was 1 liter, right? Had an initial volume of 1 liter, V2 is to be found out. So V2 is to be found out, I'll use the relation here. From here, V2 should be equal to P1 V1 upon T1 into T2 upon P2, right? Substitute the values. P1 is 155 kilopascals, volume 1 is 1 liter, into the temperature 2 is 398 Kelvin, divide this by T1, which is 298 Kelvin, into P2 is 605 kilopascals. Again, cancel out the units to make sure you plugged in the right values at the right places. K pascal goes off, so you're left with a liter, and you're looking for volume, which means you plugged in the right values. When you solve this, you'll get the answer would be 0.34 liters. 0.34 liters is V2. So let us solve one more question. So this is the third question. A 5-liter air sample has a pressure of 107 kilopascals at a temperature of minus 50 degrees Celsius. If the temperature is raised to 102 degrees Celsius and the volume expands to 7 liters, what will be the new pressure, or what will the new pressure be? Again, we are looking for P1, V1, T1, P2, V2 and T2. 5 liters is V1, has a pressure of 107 kilopascals is the pressure, and the temperature is minus 50 degrees Celsius. In order to get the temperature in Kelvin, we always add 273. Add 273 to it to get the result in Kelvin. So how much would this be? 3, we are subtracting 50. This would be 2, so 223 Kelvin is the temperature T1. What is raised to 102 degrees Celsius. 102 degrees Celsius plus 273, we have to add again to get the Kelvin temperature. It would be 7, 3 plus 2 is 5, 7, 3. 375 Kelvin would be the temperature. 223 and T2 is 375 Kelvin. If the temperature is raised to 102 degrees Celsius and the volume expands to 7 liters, P2 is expected of you. Okay, so we have the relationship is P1 V1 upon T1 upon T1, my mind is moving faster than my fingers, is equal to P2 V2 upon T2. Now we're looking for P2, so we'll flip this and we'll keep this here like this. So P2 would be equal to P1 V1 upon T1 remains as such, and T2 would go up here and V2 would come down here. So this is the relationship. Now substitute the values in order to get P2. P1 is 107 kilopascals, V1 is 5 liters, and T2 is 375 Kelvin. So we're done with the numerator. Come to the denominator, we are looking for T1. T1 is 223 Kelvin and V2 is 7 liters. Now cancel out the units so that you know you get the right units for your answer. Since you're looking for pressure, your answer should be in kilopascals. So Kelvin and Kelvin are cancelled. We get kilopascals, that means we plugged in the right values. And when you solve this, you'll come to 128. 128.5 kilopascals will be your answer, right? Now these were 3 numericals from the New York Prentice Hall textbook. I will now solve one numerical problem from the NCERT textbook exercise. And I think after that, we should be good with this topic. Give me a moment. Okay, so now this is question 6 from your NCERT textbook exercises of chapter 5. So it's question 5.6. The question reads that the drain cleaner DrainX contains small bits of aluminum which react with caustic soda is sodium hydroxide, to produce dihydrogen, that is H2. What volume of dihydrogen at 20 degrees Celsius and 1 bar will be released when 0.5 grams of aluminum reacts? This is all that the question reads. So you are expected to know this chemical equation between aluminum, sodium hydroxide to give you sodium aluminate and release hydrogen gas. Once you know this, once you write down the balanced chemical equation, we find out the quantities that would be there at STP. Why STP? Because we know that 1 mole of any gas at STP, that is standard temperature pressure conditions, has a volume of 22.4 liters or 22400 milliliters. So using this information, we will find our P1, V1 and T1, and then we'll use the information further to use the combined gas law. According to this equation, aluminum has a mass of 27 grams, that is the molar mass of aluminum. There are 2 moles of aluminum, it means that 2 into 27 would be 54 grams. So you're using 54 grams of aluminum, and how much of hydrogen would be produced when you use 54 grams of aluminum at STP? You will get 3 moles, that is 3 volumes. So 3 into 22.4 liters or 3 into 22400 milliliters. Now that we know the quantity that we have is 0.15 grams, and remember the combined gas law assumes that the quantity of the substance is fixed. So when it says 0.15 gram and we are taking 54 grams, let us find out what would the amount of hydrogen be, or what would the volume of hydrogen be if we used 0.15 grams instead of 54 grams. So use unitary method. When you use 54 grams of aluminum, the amount of hydrogen produced is 3 into 22400 ml, right? If you used 1 gram of aluminum, you would have got upon 54, and if you used how much? 0.15 grams, then what would the volume be? The gram and gram would get cancelled, and if you solve this, you would get 186.67 ml. 186.67 ml of hydrogen, right? 186.67 ml of hydrogen you've obtained when you used 0.15 grams of aluminum at STP. So now we are looking for P1, V1, T1 and P2, V2 and T2. We know the pressure one, standard temperature pressure. Temperature is 273.15 Kelvin. Pressure is 1 atmosphere. Let us write it in atmosphere. We'll change the bar later. And volume that is given to us is, that we found out, is 186.67 ml. Right? Now pressure 2. The drain cleaner DrainX contains small bits of aluminum which react with caustic soda to produce dihydrogen. What volume of hydrogen at 20 degrees Celsius, we're looking for V2, and the temperature is 20 degrees Celsius, add 273 to this, you'll get 293 Kelvin, and P2, 1 bar. So convert 1 bar to atmospheres because we've got atmospheres here. So 1 bar to atmosphere will be, 1 bar is 0.987 atmosphere, 0.987 atmosphere. So we use the atmosphere and let us solve it. Let me just write the later part first. P2 V2 upon T2 is equal to P1 V1 upon T1. Why? Because we are looking for V2 And now what would V2 be equal to? V2 would be equal to P1 V1 upon T1 remains the same into, we are looking for V2, so T2 goes up here and P2 comes down here. Now substitute the values. The values are P1 is 1 atmosphere, V1 is into 186.67 milliliters, and into, we are looking for T2. T2 is 293 Kelvin. So we got the numerator here. T1 is 273.15 Kelvin, and P2 is 0.987 atmosphere, right? Now let us cancel out the units to make sure we plugged in the right values. We are looking for volume, so our answer should be in milliliters. So Kelvin and Kelvin get cancelled, and now when we solve this, 203 ml, right? So when we solve this, the amount, the volume V2 that we get would be 203 milliliters. So this was the combined gas law. If you found the video helpful, please give it a thumbs up. I'd appreciate that. Subscribe to my channel, share my videos with your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.